Okay, our second chapter is to do with numerical analysis on number theory and something called the Euclidean algorithm that we will investigate and explore later. We're going to learn about how to use the division algorithm, how to convert number bases, and then how to use both of these skills to help us with the Euclidean algorithm as we progress through this topic. It's part of a section called numerical analysis, which means that you've got lots of iterations and repeated operations that take place here, and they're for computational processes and basically programming. So if you think about the foundations of programming, you might have heard of binary before, ones and zeros. You're going to learn how to deal with number bases and how to go through processes. Is 2 times 3 equal to 7? You're thinking of my tree. Of course it's not. You know, 2 times 3 add 1 equals 7. Why am I doing this? So we're going to look at how to set up things for division algorithms, and you have to have an appreciation of how we do that. So similarly, you could say 7 was based on 2 times 3 add 1. Okay. Before we learn about the Euclidean algorithm, we're going to appreciate how to use the division algorithm. So let's think about what we were doing there. We were saying how many 2's made 7. So you know that if you were saying how many 2's were in 7, you'd say 3 with 1 left over, so 3 remainder 2. So this is the divisor. So we're dividing by the 2, and this is how many we get out of it, which is 3. So this is what we divide by, and how many you get out is called quotient, and then what's left over is the remainder. You came across these words in functions and higher, but this is purely numerical now. So you can reverse this and then say that 7 could have been, instead of dividing by 2, 3 times 2 add 1. In the division algorithm, we don't tend to use a times, we use a dot. And you'll see it's how many times we had the divisor going into it, and then the remainder. So when we have this, you don't have to know A, Q, B, and R. What you have to realise is that whatever your number is, if you were told that you were dividing it by 2, then this would go here. So 7 is 2, 2 goes into it 3 times, and you've got 1 left over. Some things to think about for the remainder. There's some kind of answers you wouldn't do. So you wouldn't say 7 equals 4 times 2 take 1, because you're not allowed a negative there. So one thing to realise is that the conditions is that you're not allowed a negative. Another thing you're not allowed is for the remainder to be larger than the divisor. So we were dividing by 2, so you wouldn't say that 7 was 1 times 2 add 5, because 5 is much bigger than the divisor. You can still get 2's out of that. So you have to think what's the most amount of 2's you can get out. So that's 2 things to realise. You're not allowed a negative remainder, and you're not allowed a remainder that's bigger than what you're actually dividing by. Okay. Also, when we go to do this, you'll see in the previous one I had a little dot there. Instead of having times, I would say 3.2. It's not 3.2, it's 3 times 2, and we use a dot. Sometimes you see that when we use the chain rule in differentiation and integration, instead of a multiplication sign. Okay, it's choice, but it's actually just nicer to see when we go through lots of operations. Remember that it has to be positive and less than the divisor. So let's have a look at issues that you might come across. So if I said to you, what's the connection between 33 and 4? Then I would hope that you would think about the appropriate number for 4, but what's wrong with this? Why is this not a solution? Have you figured it out? 4 goes into 33 how many times? And what have you got left over? Why is this not? This isn't a solution because you could say 7 times 4 add 5, but if you're dividing by 4, you're not allowed a number that's bigger than 4, so that's why it's not. So the actual response should have been it goes into 8 times, which I would naturally hope you do, with 1 left over. Okay, I've exaggerated the space there just to remind you it's not 8.4, it's 8 times 4. Okay. If looking for a connection between minus 29 and 6, why is this one not right? So we've said minus 4 times 6 is minus 24, and then take 5 more. It's not a solution because you're not allowed a negative here. So how would you get that answer? Instead of minus 4 times 6, what about minus 5 times 6? So how many 6's are in that? You could say minus 5, which goes to minus 30, and then you could add 1. and then that would be your solution. Okay. So remember, your number must be positive, you can't have a negative, and it can't be bigger than the divisor. Okay, it has to be less than the divisor. So what are you going to do? You're going to try. So remember, if I said how many 4s were in 33, I'd say 4 goes into 8 times and you get 1 left over. I'd have to think about negatives and be careful about them. So how many 6s are in minus 29? Think about 6 5s are 30, so go bigger negative and then go back up. Okay. These both questions are from Scholar, page 190, 32 and 33, but you don't, it's only 2 questions you're going to do just now. So they're here in front of your face, so you can just pause them and do them. And what you'll find is I'm about to go over the answers, but I'm going to stop this video now and then we'll bring back up afterwards. So you can either use these or these. I'll keep these ones on here just now so that you can see, and that's what your task is for just now. Okay.